Hello, my name is Gabriel Fiol, and for my final presentation, I'm going to do it on Project 1, which is the conventional surveys for setting ground control points. This project was done in 3 phases, with the first one being setting a planimetric survey where we find the X and Y coordinates. Phase 2, where we do a level run and assign elevations, a Z coordinate to the ground control points. And then Phase 3, where we compile all of the data that we got from the first 2 weeks of surveying and put it into Microsoft Excel. I picked this project because being able to do ground control is basically the backbone of UAS mapping, where you have to be able to set and know the coordinates of the points in which you're eventually going to fly over with an unmanned aerial system. So our study site is Flavet Field, where we have 4 known control points, U, West, South, and W, and the unknowns are going to be points A through I, which are those 9 right there. All of our points are iron rod and caps, and we are given the X, Y, and Z coordinates of those 4 control points surrounding those 9 in the middle. Phase 1 is our planimetric survey, where we set up the total station on one control point and backsighting the opposing known control point, where we do direct shots on all of the unknowns, reverse the scope on the total station, and then collect the same shots on all of those points. And then we do that for 2 setups, so that we have a direct and a reverse, eliminating any biases for the gun drifting in either X, Y, or Z direction. Phase 2 is where we do the level run, where we have the known elevations, where we backside off of, instead of using an automatic level, we backside off of the known elevation. And then since all the control points are really close together, you can hit foresight all those unknown control points grouped together in one shot, and then turn off of one of them and check into another known control point with the elevation on it. And we did that for 2 different control points, where you would go the other way to check in to make sure that the level run was good. And then the last part was the data processing, where we got all the field notes, all the data that we got into the field, and compiled it onto Microsoft Excel, where we got the horizontal angles, the coordinates, found our departures and latitudes from each of the points, and assigned the XY coordinates from those direct and reverse shots, averaged them out, did our statistical checks with our residuals to find how much, and as well as for our level runs, doing a statistical check and averaging out those elevations to then come to our final coordinates for the ground control points. And in conclusion, doing the conventional survey, we were able to get an accuracy of around 1 centimeter, less than 1 centimeter, which is really good. And all of this is necessary because, as I said before, being able to set ground control points is basically the backbone of unmanned aerial systems for mapping. And the other methods that we would use, which would be, using Survey Pro with the data collector, you could just do a repetition shot for each of the points instead of having to individually write down all of the direct shots and horizontal angles for each of those. So there's more tools out there to use, but for our class, doing the angles and the distances to actually see what we're doing is important to understand why this works. Thank you for listening to my presentation. Have a great day.